Kendor.
Kenceng keseng gitu. Saya tak sangkut ya. Sorry ya.
Communicate with me in Korean. Thank you.
You know, for people
카메라 5대랑 영상 못 찍는 거 없을 것 같아.
카메라 5대라고?
근데 너무 잘 보여. 할 때는 그냥 어차피 터치캠이라서. 근데 3인인 줄 알았어요. 크긴 하거든요. 그러면 가서 제가 조정해. 네. 이거는 이거 2개밖에 없는데. 네, 정면 캠. 보여드릴까요? 비교가 안 되나? 가야 되겠다.
Good morning, ladies and gentlemen. It is a great honor and pleasure to welcome all of you to today's seminar on appropriate technology and environment. I am Nelson and this is my partner.
I'm Hannah and,
And
we are the Master of Ceremony for today. Before that, we want to say sorry for our English skill not good. We would like to extend a warm welcome to all of you for taking the time to attend this event. It gives us a great pleasure to the Master of Ceremony for this seminar, and we are excited.
The Honorable Head of Chemistry Education Study Program, Mrs. Natalia Hapsari, SPD, MPD, PhD, whom I respect the speakers at today's seminar who have taken the time to share their knowledge with us. First of all, let's give praise and thanks to the Almighty God. Because of His love and mercy, we all can gather in this place.
We are honored to host this seminar today, and we would like to begin this session with a prayer that will be led by our friend Aurelia. For Aurelia, this time is yours.
Good morning, ladies and gentlemen. Let me lead the prayer according to Catholic religion. Let's pray together. In the name of the Father, and the Son, and the Spirit. Amen. Dear Lord, we give you thanks for the gift of life and for the opportunity to serve you today. We ask your guidance and protection as we embark on our activities. We ask that you help us to be mindful of your presence in all that we do, and to always act with integrity and honesty. We ask your blessing upon all those who will be involved in our activities and upon to the work that we will undertake. We pray that our effort may be a means of serving you and your people. We give you thanks, O Lord, for your goodness and for your mercy. We ask that we may always be grateful for your blessing, and that we may always be mindful of love for us. By Christ, our Lord and Savior, who lives and reigns now and throughout all the time. Amen. In the name of the Father, of the Son, and Holy Spirit. Amen.
Thank you. Now I invite everyone to stand up and sing the national anthem of Indonesia Raya. Thank you everyone, and please sit down.
We have an exciting lineup of speakers and event planned for today's seminar. And we hope you will find it interesting and informative. Let's get started. Now, we will listen to the welcome speech by Mrs. Natalia Hapsari SPD MPD PhD as head of the Chemistry Education Study Program.
Everyone, give applause.
Good morning. The
faculty member in chemistry education, Sanata Dharma University. Good morning, Dr. Jung Mi Ju, Dr. Min So Mai, Dr. Hung Yun Park, and Mr. Jun Tek. Welcome in Sanata Dharma University and Annyeonghaseyo. We are very happy because you come in our university to share what did you do in Korea to our student. And good morning, my beloved student. Are you ready to hear the seminar today? Okay. Our seminar today is very useful for us because we can enrich our insight how to develop the learning media to apply the technology and environment. And then, okay, have a nice seminar today and thank you.
Thank you, Mrs. Natalia.
Now, the moment we are looking forward has come. That's the material presentation session for our speaker. This material presentation will be divided into 2 sessions and will be guided by the moderator. Firstly, let me read the curriculum vitae of the moderator. Yasinta Claudia May is an active third semester student at Sanata Dharma University who is currently studying in bachelor degree in the chemistry education study program. During approximately 1 year of studying, she has been active in various activities and organizations on campus. In committee activities, she was on the INSIPRO Chemistry Education Committee as coordinator of the event division and on the 7th anniversary of Chemistry Education Committee as Convention Division. Currently, she is serving as a member of the KPU Division in the HMPS Chemistry Education period 2023 and 2024.
Without further ado, I leave the next session to the moderator. For the moderator, I invite you to the stage. Time is yours. Let's give applause.
Mau dibuka dulu atau gimana? Pindah.
Okay, annyeonghaseyo, 여러분. Okay, so good morning, everyone. Thank you for this opportunity that has given to me. I'm Lei, and it's such an honor for me to be the moderator today to guide this seminar. And first of all, I would like to apologize if my English is not too good, so I kindly ask for your understanding. Okay, so as what the moderator said before, that this seminar will be divided into 2 sessions. There is first session and second session. So before we begin, we all have been waiting for, that is the presentation of the speaker. So for the first session speaker, I invite you to take the stage with me. Let's clap our hands for our speaker, please. Maybe you can introduce you. Yeah.
Good morning, everyone. It is very nice to meet you. And then I would like to express my sincere gratitude to the organizer, the chemical education program faculty students here of Sanata Dharma University. Thank you.
Hello everyone, my name is Min Soo-Mae. I'm working in Dangwon University, South Korea, and I'm Director of Science and Engineering Without Borders. Anyway, it's very nice they me, and it's very good honors. And then actually I'm the second speaker actually. So have a good day.
Okay, thank you for your short introduction. So now let's just move to the main session. That is the presentation of the material for today. So for the speakers, time is yours.
Do I talk and sit this way?
It's up to
Do I stand up?
Yeah. It's up to you. Just stand up or sit up.
Okay. And then what here?
You use
If I sit at the top, what here is in the back side. So, shall I?
It's okay.
Then that means I should close to see my Okay. Okay, because my presentation material is on my backside, and then so I move my position. Okay, screen is here.
It's both sides.
Yeah, both sides. So I will look. Then somebody wanna you can see like next. Okay. I will give you a cue, like next. Okay. Okay. Hello, everyone. Again, it is my honor to give some talk with this beautiful young students in Yogyakarta. And my topic is the overview of appropriate technology and sustainable development. And I am a board member of Scientist and Engineer Without Border, SCW, and also a member of Academic Society of Appropriate Technology of Korea. And please. And okay. And my presentation is not my own creation. It is the presentation from collective knowledge from my colleagues. So I will start my presentation. And since I'm going to talk about appropriate technology, and then I asked GPT again. So, because ChatGPT has big data about the appropriate technology. Okay, thank you. Okay. Is here?
Sebidang. Misalnya mau di belakang ada elevator. Elevatornya buat
Okay, so ChatGPT mentioned that I asked what is appropriate technology, because ChatGPT give us an information about the most popular way, on the logical way, and ChatGPT said that the appropriate technology is simple, affordable, sustainable solution that meet the needs of local community without causing ecological harm. And also, it is designed to be easily maintained, energy efficient, accessible. So if you see the orange color, it's described the feature of the appropriate technology, which is simple, affordable, sustainable, easily maintained, accessible. Okay, so live straw. Have you seen live straw before? Yeah. Well, this is many times. It is the good example of the appropriate technology for the safe drinking water, because this live straw is the canned live straw can filter and treat from the raw water to the clean water so that you can drink by sucking like this, like straw.
Okay, so the presentation will be switched with the second speaker first. So Dr. Yumin Ju will be the second speaker. Thank you.
Sorry about that. We changed the speakers. Actually, I was supposed to second speaker, but so I want to do the first one. Right. Let me introduce myself again. My name is Min Soo-Meng. I'm working in Dangun University. My major is civil and engineering, environment and science engineering. And so today, I'm going to explain the appropriate technology in the world. Listen carefully. The appropriate technology, maybe she said, right? Here we mentioned about that. And then I'm going to shortly give the introduction about the appropriate technology. Sometimes we think about it, appropriate technology means just for developing country? No. No. In our Korea, also Japan, USA, they already use it appropriate technology. So I'm going to show the reasons why this technology is very useful in the world. Okay? And then look. So today I just prepared just case study. In the other countries, I did a lot of experience, and then in my lab, I made it just technology for appropriate the situations, and then I just tried it in the on-site in the different countries. Or as you are the later in the future, you're gonna be the teacher, right? So in your class, through this can be just a weapon for you, for your teaching method, teaching skill. The with you do, and you will do that together. Very easy, and a very easy technology, very easy just the methodology for the appropriate technology. So, listen. Okay? Right? Working? Oh, it's not working again. Or maybe I think we need a distance, right? So this is my content. The first of all, what is the appropriate technology? So I'm going to explain the real one. And second one is I'm going to introduce a little bit my just organizations. I'm just the board members, and I'm director of just scientists and engineering just borders. Of course, right? That's my second job. And the third one, final, the appropriate technology case study in the country. Of course, I told you, this technology can be adapted, right, in the developed countries, right? In Korea also we are using it, still now. So look, this is the last tour, right? I told you this last tour. In Africa, sometimes to get the clean water, to get the safe water, sometimes we can use that one. But in our Korea, we are using that one. For example, if we go to mountain, right? Mountain, the razor, the activities, we take this one. We take this one, and the climb mountain, and the no water, we always spend water with that filter, just to use it, just the blaster to get the water from the stream, the pond, right? In the mountain. In the mountain, you can find this spring water, right? But if we drink directly, spring water is not good for you. But if you use this one, you can get the safe water. That's why this is just a appropriate technology for the providing safe water. Got it? That's why, think about it. Look at the just a light feature. This is a water fire. Maybe you have. Got it? And then left one, also this last one. Compare with them, both of them. Right one is very expensive to provide clean water. The left one very cheaper one. But when compare water quality, both of them shows same water quality, same one. It means the product provided same water quality water. But the features, this is just household time. But left one, right? Right, and left. The left one is just in activities. Or if you go to somewhere, go to the picnic, right? You can use that one to get the clean water. Understood? Right. This is an appropriate technology. So even I'm just the professor. I'm just studying. I'm researching in my lab, and then we are focused on low cost, high efficiency, and low energy. People want actually when we make it just product, water facility, water equipment, with water device, sometimes these devices can be very, very expensive. But with recovery, for cost-effective, and then save money, and low energy, low cost and high efficiency, yeah, we are focused on that. That's why sometimes for my product can be available in the developed country. So listen carefully here. This is a big Latina. Look, maybe you have the smartphone, right? Apple, Galaxy, is it? And then smartphone actually has the camera that functions the device. The smartphone has very, very good quality camera. Sometimes, if somebody live in the very far from the city, and then there are somebody that stay in the countryside, but somebody use their smartphone, and then if they have some problem eyes, and then if he go to the hospital, it's very hard to go there because the long distance, right? But somebody just took a picture in his eyes and sent the photo to the doctors. Doctors check his eyes, and then they will just state that he can do that, just a diagnosis by just a smartphone, by just message. Okay, it's okay, you are okay. You just clean your eyes and clean by yourself. It's okay, but okay, you have a big problem, carefully to come to hospital. This is just appropriate technology, right? So, this is ceramic filter. Have you seen ceramic filter in your area? Raise your hand. Have you seen ceramic filter? Maybe this is very, very popular filter in here, in the Cambodia. The Cambodia also use this one in your school, not university, just the elementary school and primary school. Very, very popular one, the ceramic, and then this ceramic can remove microorganisms, kind of just E. coli and bacteria. So we can prevent the water disease. Use the ceramic filter. Very cheaper one. Because now in this university, there are a lot of the water purifier. The purifier consists of several filters, kind of usually 4 filters: the sediment filter, and the free carbon, and the Europe membrane, and post carbon. That's why that is expensive, right, to buy them. But if we use the ceramic filter, very cheap one, maybe this price of the ceramic filter will be maybe less than $10. Less than $10, you can get the safe water. Why? With just the water purifier system. This is the appropriate technology. So, if you teach with your student, if you have classes, your student, and then you can make this filter, and then you will train how to design this filter for your student. This is very, very useful, the method, teaching the weapon. The other one, this is a seawater. This is desalination technology. Maybe I know, maybe Indonesia has a lot of island, or sometimes somebody in Indonesia uses that technology to get a clean water. Very, very simple one. And then this is just the fresh water. Also, it's okay. You can use it just seawater. It's okay. But fresh water, seawater, it doesn't matter about that. And then if you put the containers, and then the water is evaporated, and then evaporated water, and then condensing, and then we can get the clean water. Got it? This is a very useful one. So, if we go to somewhere, if we go to sea, right, and then you only expand the water. So if you use that technology, you can get a clean water well. So this is it is appropriate technology, right, about the water field. very beautiful one. And another one, everything is more con, the same things, same things. Usually in the dangerous area, right? In Africa or desert area, and then they need clean water or drinking water. But actually, if you use this system, this technology, and then you can get the water easily. Very big, simple one. So think about it. I told you in our Korea, in the leisure product, we have a leisure product. So bicycle. So maybe think about it when you climb the mountain, and then we only spend the water. So maybe sometimes, so in the or in the night, we put that system on the land, and the next day we can get the water. Very easy, right? Sometimes you could try this technology to get the water with the appropriate technology, just sitting, just provide. This is also solar water. Sometimes maybe you have electricity, right? So you have the light. But if you go to countryside, no electricity, no light. But if you use that system in the daytime, so inside house, that can be very dark, no light. But if you put some bottle, so bottle can be the bright light, right? The light can be you find it just the light inside with just bottle. Also, this is a tea bag, like a water filter. This is just assumption, just technology. So sometimes the assumptions, right? Maybe that observant can observe some materials, some kind of the inorganic matters, the calcium, the fluoride, arsenic or fluoride, and kind of lead things, right? This is also very nice the technology for other substances. Another one, have you seen just reverse osmosis for desalinations? Sometimes we think about it. So maybe if we go to water from the sea, right? We can use just the desalinations. Desalination means from the sea to fresh water. But we think about it. This is very, very expensive technology. But no way. This is very cheap one. You can do it by yourself with that system. So I mean, sometimes, and the very low cost, low energy, and then you can make out just the desalination technology, right? We call that this is just appropriate technology. So, okay, let me introduce a little bit about the organizations, the scientists and engineers with borders. This is the one of the NGO in Korea. We just provided several technology to the world. And agriculture, medicine, and water and wash, and the ITC, everything. But my major is wash, water, and sanitation, wash part. So I just provided just wash technology as the appropriate technology. So we are the vision, the very world in good science and engineering. And the mission developing our sustainable technology, sharing the experience and knowledge for people who is interested in the humanitarian technology. And we just shared our technology to people. I think this is a good spirit for you, right? As I'm a teacher in our university, also when I teach my students about that technology, right? And then, so I just give them that spirit. So as we have to share our technology to people. So we have to just provide it, the good things to you, for nations, for your people. So we have several activities, and anyway we have support activities recorded appropriate technology, and then we will share just the seminar and the workshop, or just give the technology to them, or any kind of some activities. In the world, here and then Africa and Ghana, Burkina Faso, and Cambodia, and Vietnam, any countries, we just provided appropriate technology for them. We just share several the field. And the seminar and volunteer the competitions and any kind of conference. So every week we have an international conference, annual conference, and the last month we did it international conference in the Bali, right? Last month I met some professor in the university. So sometimes with the project we just provided some opportunity to people project, and then the development and cooperations and kind of everything. Education and the volunteer activities. Especially, so in our organization, we provided just education program for high school, for university students, for the private school, because they want to learn that appropriate technology. It's very, very, very interesting activities for them. So we have just book, textbook, and we just provided the educations, and especially two things: the lecture class and the practical classes. So we provided both of them, right? Very important, the lecture and the practical. You see, right? Okay. Now I'm going to show our just experience in the world, and I just selected some of the countries, and Mongolia, Ghana, Cambodia, Ethiopia, Tanzania. So of course, we are providing some any other activities in the world, but actually I just pick up my field, the world and the ocean field. First of all, Mongolia. We did an international appropriate technology camp. I think with camp, maybe at the time, just we did it just 1 week, and not 1 week, maybe 4 nights, 5 days. With the student from Korea and Japan and Mongolia, and we gathered in the Mongolia, and we did a camp for the international appropriate technology camp, and we just taught just the wash part, ITC, and the solar, and any kind of things. First, I told you, we did 2 parts. One part is just the lecture course, another part is just the practical part. So, at the time I did it, I taught the BSF, biosensor filter. Biosensor filter means to provide clean water, and we just prevented just oral disease. We removed just microorganism, kind of E. coli. And then, first of all, I taught just theory and lecture, and later we did it practical, the lecture classes. I think it's good. I was very nice the experience, these activities. And then look this one. This is the trickling filter experience. Sometimes trickling means, and then we can just circulate the water automatically, right, by pump. And then later, the water can be, first of all, the origin water is very, very just polluted. But with the trickling filter, and then our water can be just treated by the microorganisms. Later, let me introduce about that, how to treat the water, right, by the treatment filter. So in the Mongolia also, I made it just the corn salad. Corn salad means the livestock feed. Feed means just just feed the instead of just the dry lay. So I think especially in Mongolia, in the winter time, and they have a lot of the big strong snow, and then they have a nomadic the people, and in the winter time because snow, the livestock cannot eat the feed the plant because the all of the land is covered with snow. That's why it's not enough to feed, right, for the livestock. So just to provide this, the feed, we just like the corn salad. Maybe I think you know salad, right? We just started corn. Of course, there are several salads, but in the Mongolia, the corn is very popular, very nice the plant for the cultivating. Okay, this is the Ghana side, right? The Ghana also used just the water from the groundwater, not surface water. There are almost people that drink from the groundwater. But as you know well, some households have their own groundwater, own well. It means they just pick the land, big well. With big well, they use big well, and they use it by themselves the groundwater, the drinking water through the well. But problem is that the water is contaminated some pollutions. So any other just the trash from the trash or any other just some pollutions the enter to groundwater. Still, they use the polluted water. They drink the polluted water. These big problems. That's why. And then we just provided just the water purifier system, simply one. Of course, I told you, right? The people, when I show that the slide, we have a very expensive one and a very cheap one. Expensive one is the purifier system in your university. Cheap one, live things. But we just focus just very cheaper and very low cost, and then we just provide same high the water quality. That's why we just decided on the filter. So the Cambodia case. So we are focused on the wastewater. It's not drinking water. We are focused on the wastewater, how to treat the wastewater. And then sometimes in this university also we have immediate discharge wastewater from the house, from the toilet, from the chicken, right? And also we installed this treatment filter in the inside the university. And then maybe from the dome, right? Dormitory, and the dormitory just discharged wastewater and we together in the pond. And then we treated with wastewater using just treatment filter. This very simple one. Immediately, first of all, when I check the wastewater, this is the after treatment filter, the water in the change to clean here. And then we just release, we just discharge to land or plant. I think, so this is very simple. It's not high technology, right? Very simple technology for you, right? Just stop the stones, and then you just circulate water. That's it. This is a natural system. Look, this is a BASF. Let me introduce again BASF. Why BASF has very powerful just technology for providing safe water. The BASF, the biosand filter, and this is a BASF here. And the very important thing is the sand. Sand, the size of sand is just 0.45 millimeter. Very important. And then we need to keep the depth. Minimum 40 40 centimeter. So think about it. This is just for I told you to provide clean water. So we just focus on just how to remove the microorganisms, kind of the E. coli. The E. coli is just microorganisms. E. coli need to live. They need the oxygens, right? And then if you put water, contaminated water, so water contain the E. coli to family. Okay, yeah, calculate, right? So anyway, this is just very simple technology for you, right? Also, for this community level time, this is very simple one, and then the beeper and then the water. This is a low water quality, and after installations, so we can check the turbidity and then ion and conductivity, everything. Very simple. This is the BSF technology. BSF. Or in Cambodia, we have the SBBR, the technology. Also, look this one. This is the sequencing batch, the biofilm vectors. And then to provide clean water, we use the microorganisms. The microorganisms remove just microorganisms. The main microorganisms can kill just bad microorganisms. We use that natural system. And also this is the ABL, anaerobic biofilm vectors. This is septic tank. Septic tank. And usually in the countryside, they use it. The soaking pit type, the left tank, but in our technology, and we might need just ABL. ABL means just the anaerobic biofilm vectors. So in Cambodia, we just found out we installed just ABL system in the high school, secondary school. Or this is just disinfection the device. This is a commercial one. We put the salt here, and we just provided electricity, and we found you can get just the disinfections. And the toilet, compost toilet, and then this is we call it eco toilet. When you go to the toilet, we gather the two things, the feces and dung, right? The feces is for the fertilizer, dung is we can make it composted, right? We just provide compost to agriculture field. This is just the fluoride absorption using one. I told you yesterday. I just introduced that the bone technology to provide it to remove fluoride. This is the Ethiopia case. Think about it. If you're interested in the agriculture, especially mushroom, oyster, usually you just plant the oyster in the outside, but it's okay. You can grow the oyster inside the house. This is the appropriate technology, right? Very easy, yeah. And then after that, we eat the oyster, and then we just sell the oyster to the company or the hotel restaurant. It's a very economic system. Also, and in Ethiopia, we just planted, we install just water purifier system using just a bio sand filter. Right? We use that just the solar system, and then the Tanzania also. I told you this one is the community level, the water purifier system using the ultraburn. There's a bone chart. This is the Tanzania case, the last one, and the biogas. I think this is very useful the technology for your country, right? Because the temperature is available. But so the biogas provides just energy, the methane. So the methane can use in the kitchen, the restaurant, the no energy, right? So you never buy just LPG, other things. by yourself, you can get the energy through this biogas plant. So, especially now, I have a project in Tanzania and provide this methane gas. So now, actually, I provided the methane gas. It's free, no cost, right? Right? It's very, very good, beautiful methodology for the appropriate technology, right? Okay, this is my just experience in our university, in our organization, SEWB. Thank you very much. Thank you for your attention. Okay, done. Thank you.
Okay, thank you for the first speaker. So now maybe we'll just move to the second speaker. Okay, okay, time is yours.
Closure. Okay. It worked fine. Because I talk after Dr. Meng, so I can make it shorter. Okay. Okay, I will start. My presentation is about the overview of appropriate technology and the sustainable development. And then he asked Wikipedia, I asked ChatGPT. And it shows the feature of the appropriate technology. Okay, this is. And then he showed this the example of the light draw, right? And then this can be used like emergency situation, or that drinking water is not supplied in the normal situation, like that. And as he showed, and fundamental technology is the same, but this shows that how to use this technology, that's different. And this is another example of solar disinfection technology. You see, as you see on your table, we use bottled water a lot, and then make the plastic waste. And you see on the right side, lots of plastic waste, but in somewhere it could be used for solar disinfection, disinfect the pathogen. And as of 2007, more than 1 million people got the benefit. Okay, and so what is appropriate technology? Some people also say that the technology for the basic need of people. First, ChatGPT mentioned more about the characteristics of the appropriate technology. And here's technology for whom? Technology for the basic need of people who may be neglected from the benefit of technology. So many times we say science and technology for other 90s. 90s are most of the people, but and also sometimes low-income group, bottom of population, and about 4 billion, that is half of the global population around the world, also may need appropriate technology. So this is the appropriate technology, I believe, and that is the good technology, I think. And this technology deems most appropriate technology, most appropriate within specific political, economic, social, cultural context in a given era and the region. So it could include innovative technology aimed at the solving social issues and advancing social progress. So this concept reflects the philosophy and direction of the scientific and technological development. See, this is what is the appropriate technology to Korea about 60 or 70 years ago. That is right after the Korean War. That is the situation of our society. And now, Seoul in 2015, Seoul is very well urbanized, well developed. And what is the appropriate technology? Long ago, we wear the shoes made of rice straw. And at that time, making a rice straw shoe could be appropriate technology. And now, everybody has a smartphone. And smartphone technology, that one could be used as an appropriate technology too. And from the Gandhi spinning wheel around the 1930s to Schumacher's Small is Beautiful around the 1960s, and up to the Millennium Development Goal starting from 2000. The spirit and history of the appropriate technology has been embedded and developed. And now, SDG, the new Global Development Goal adopted by UN, started from September 2015 for the period of 2016 to 2030. This is the universal goal applied to all countries. MDG was for the developing country, previous one, but the SDG is for the global universal goal, not only developing country, but also developed country for the balanced development, social, economical, and environmental aspect. So, but now we are also living in the era of global climate crisis. So this one is the maybe most threatening factor of sustainable development. We have more frequent natural disaster, the higher magnitude, and so we need carbon neutral engineering or climate technology, saving energy, And so those one, if we refer it to a technological system and technology that minimize or offset carbon emission by maximizing energy efficiency, utilizing renewable energy source to reduce carbon emission. And also it can refer to the innovative technologies contributing to greenhouse gas reduction and climate adaptation. So this could be new form of appropriate technology. And if I introduce our activity, Scientists and Engineers Without Border was established from 2009 in Korea. I will skip. And then we had many activities as Dr. Meng showed in the world map. We also had a service established the solar plant in the other world. And also we had a collaboration with consumer group. Like when that consumer group sell this bottled water, and the consumer collect cap, and then that cooperative co-op donated the money for cleaning drinking water in Cambodia. And also we made a collaboration with medical doctors. This is Lee Jong-woo, JW Center for Global Medicine. And also we try to develop some business model of appropriate technology, had some workshop, and also some venture companies using drone had the mapping of the earthquake affected area in Nepal. And this one also he introduced. And then here I would like to mention that we developed some technology. This technology is maybe well known, but making this product is another one. And so we want to use this technology in cooperation with company, so can be used much more easily. Right? Okay, I will pass. And then we extended our activity from volunteer service to the academic activity. So Academic Society of Appropriate Technology was created in 2015. So this is the first international conference for appropriate technology hosted by Academic Society of Appropriate Technology with the theme of appropriate technology for sustainable development. And then since that, we have international conference every year with different theme. And I hope you could enjoy. You could join us. And also, we published the journal of appropriate technology. And so we publish it more frequently, recently. And also you can submit your researches or activity to this journal. And then we have workshop, maybe another form of like this seminar, and in outside the Korea, like Cambodia or Tanzania with Dr. Meng. And then this year, oh, you didn't wear that shirt. Yes. Okay. And we had that international conference in Bali, Indonesia, this year. Okay, so I will summarize my presentation. Appropriate technology is one of the mainstream activities for sustainable development. and appropriate technology activity need to be designed and proceeded with the local partners, and horizon of appropriate technology can be expanded with other disciplines like medical or others. And simple and economical water technology could be a good start. And sustainable business plan, including local partner, may be actively considered. So that appropriate technology, we hope that can make money too. Okay, this is the end of my talk. Thank you very much.
Thank you for the great presentation. Okay, so we have just listened to the presentation of our speaker. So now it's time to Q&A session. So for those who want to give a question or share your thoughts, you can raise your hand. And for everyone in the Zoom meeting, maybe if you have a question, you can raise hand or write it down on the chat room. Thank you. If you want to give a question, you can raise your hand.
Excuse me. Actually, we are explaining. We are into several technology, corporate technology. Sometimes, if you want, so if you want to learn about that appropriate technology by yourself, and then your class, your some team, and then feel free to ask us, right? We are ready to learn our technology, right? So anytime for your as you're gonna be a teacher, right? And then maybe you need this technology sometime for your teacher. So that's why. And then whenever, and then please contact us, and then we are ready to learn, and we will ready, right? That's why. So please, so anytime ask us. We'll explain everything.
Okay, thank you. Okay, so because no one of you want to give a question, so let me give a question for you. Okay, so you have just present the material about appropriate technology. So my question is, how to ensure that the appropriate technology is environmentally friendly, considering the limit of the resources developing, like the lack of infrastructure, the technology, and even the human resources. That makes it difficult to apply. How's your opinion about this? Maybe one of you wanna give answer?
I think that I think it is a very good question. There are many places like islands that not easily accessible to the technology. The other side of the society has, and so that's why we have international organization and so on. So the world becoming smaller and smaller. So as a humanitarian, I guess that maybe we should, like your university is Catholic, and also trying to work for the humanity, right? And so there are also many other peoples can help those situations, I guess. So that's why we want to spread our philosophy and about the appropriate technology. So anyone who can near there can help, I guess. Is it? Okay. Answer to you. Thank you.
Okay, thank you for your answer. Maybe there is any question? Yeah? Maybe in the Zoom meeting, is there any question or not? Sure.
Okay, thanks for the time. My question is a little bit simple. So, you presentation about rocks filtration, using rocks to filter the water. So, what kind of microorganism that has to be in the rocks so the filtration is good? Maybe that's the question.
You mean for me rock filter? You mean rock filter?
Yeah.
Okay. Okay, thank you for the questions. You mean in the rock filter? I mentioned, I explained the rock filter. We call not rock filter, we clean filter. So we could call it rock filter, it's okay. But let me explain a little bit carefully. And then to treat it just wastewater or to provide clean water, and we use just microorganisms. Still, now you have microorganisms here in air or in the water, right? And then God made it just very, very nice microorganisms. The main microorganisms is very strong. It means the microorganism can remove the bad microorganisms. So we use this method. Listen carefully. The rock. If you go to outside, and then you just when you just step on the rock, you can be the slippery, right? It means this is just microorganisms. These microorganisms can remove the bad microorganisms. That's why. And then when I show just the system, and we just talk the rock, and we circulate the water. The later, minimum 1 week, minimum just a few hours later, and the rock on the surface of rock that happens just the microorganisms, right? And then this microorganism can remove the organic and the bad microorganisms. So we just use the natural system. So think about it. The good microorganisms can kill the bad microorganisms. This is a natural system. That's what God gave us this wisdom. We just use this. Here's the method. So that's why the microorganism can remove and taste and odors and the organics or the bad microorganisms. So we circulate the water, use the rock, and then later maybe a few for our product. And the middle of I think after 2 days, and after 2 days using just the circulated water, then we can get the good water. Of course, it's not perfect because actually we will again filter. We use the sand filter, and then disinfections with the chlorine and the UV light, and then we can get water. So this is just a rough filter, the method.
Thank you for the answer.
Yeah, thank you for the answer. Okay, so let's just end this session because no one of you wanna give a question anymore. Okay. Oh yeah. Silakan.
Okay, thank you. Can I next? My friends at Zoom give a question. Number one of the appropriate technologies that can be used is the tea bag like water filler, as it can absorb heavy metals or harmful substances from water. However, the tea leaves themselves may pose a potential risk if they are contaminated with heavy metals, which can be harmful to the body. What efforts can be made to address this issue? Additionally, can all types of tea bags be used for water filtration, or is there a specific type of tea bag required? Thank you.
Yeah, okay. Yesterday I received similar questions. Tea bag is just the absorbent for the absorptions. And then, as you know well, yesterday I already said, depends on material, depends on inorganic matter, and then we have to use the just absorbent. For example, maybe you know well, activated carbon, right? Activated carbon can absorb and the tasty and odor and then organics. And then yesterday when I have a class, I just explained another absorbent, just bone char. Bone char is one of the absorbent for substance. This is just bone char is just calcium base, but active carbon is not calcium, carbon base. The depends on just the base one of the absorbent. They can remove the inorganic matters. So bone char actually can remove the fluoride. Of course, bone char can remove a little bit different organic matters, heavy metals, kind of things, but the removal rate is very lower. Very lower. So if you have the arsenic, this is just a heavy metal. But if you remove this arsenic in your field, you have to use just iron the absorbent. Iron absorbent, right? So iron means just iron can absorb well just the arsenic, and then bone char can absorb just the fluoride. And active carbon, it can absorb just taste, odor, and organics. It means depends on the tea bag, depends on materials. Actually, you can use you can just use remove some potent the heavy metal layers, right?
Okay, thank you for your answer. And since our time is over, so let's just end this session. And let's give a round of applause for our great speakers. The speaker, you can be. Thank you so much. Okay, so now we have time to break. Maybe it's about 15 minutes, and you can enjoy your snack. Thank you.
수 있는 정도면 조금 위험하긴 하지만 몸이 좀 자요. 이게 스트레스가 진짜 이거를 주머니에 넣어서 머리 걸어놓고 자요. 기가 있으면 좋은데 먹을 일이 없으니까 내 몸이 이제 기가 있고 실은 이게 이제 유무 정보가 인형, 이런 있으면 그때 이제 다른 거죠. 그 정도 이 카메라에 인이 없는 게 중요하니까 이 성분은 원래 있는 거죠. 주머니가 있어요. 주머니에 손 넣어서 시작하면 주문하고 그러면 이제 지가 알아서 물론 이제 연구실에 있는 거로 약간 그래도 밀무만 보이지 밀무만 보니까 오케이 굿. 그런 게 중요하고 또 재밌어요.
So now we will proceed to the second session, and in this session, we will join by the equally amazing speakers. And before we start, I will introduce the speaker first. Okay, so the speaker in this session is, the first speaker is Dr. Hyun Kyun Park, and the second speaker is Mr. Yoon Taek Wo. And now let's give a warm applause for our speakers. Let's give applause. Okay, so without further ado, I'll give time to the speakers to present the material. For the speaker, time is yours.
Thank you. So, good afternoon. I'm Yoon Pa. It's my great pleasure that I can have introduced my work and my presentation today. I used to work on some governmental research lab named ETRI, Electronics and Telecommunication Research Institute in Korea. I guess this is the largest governmental public research institute in Korea. There should be about 1,000 PhDs. And they do many things, and mostly they are doing electronics and telecommunication, but I'm a chemist, so they do also some chemistry and material science. And I see that the file is changed. I mean, did you make some change? Correct? Is so. Sorry about that. I'm sorry, just one minute. I'm sorry that I'm going to delay. So let me start. Before starting this presentation, I realized that this is the appropriate technology related subject. So let me start with something that I have experienced in my elementary school. I think that this is my first appropriate technology that I have related to the water I used to do in my life. And when I was in the elementary school, it was, I think it's 1980 something. My laundry machine, my home's laundry machine was broken. So the solenoid valve for draining water was broken. So I found that my mother was just using this bucket to take out the water and drain the water. And it was very laborious. So at that time, I read some science book. And then I found that if there is a water level difference, then we can use this kind of the hose and fill the water and put one side in the water bucket and put the other one so it automatically drains out. So my mother was free for labor. So I think this was my first time that I had the experience of the appropriate technology. Then I entered the university and the PhD. I got a PhD in the United States, and that time, I think that this is my first appropriate technology that I did in PhD. At that time, I had some project, have some water surface scattering, and of course this is water surface, so it should be very tangible. It's very dependent on the vibration of the water surface. So because we are scattered the laser light on the surface of the water, and we get the light scattering and get the signal detection. So to avoid the vibration of the water surface, normally what people do is they use this kind of some vibration isolation table. Somebody said the optical table, which is floating above the air by using some mechanism of the air pump. So very heavy table was floated on by air. This is very common tool for physics, especially they are doing some laser. And of course, this kind of thing is very expensive thing. And my supervisor was that the person who wants to make the students can do everything. So what we did was like this. We just hang more than 1 ton of the table on the air, like this kind of some seesaw, like this. So graduate students make concrete block, and they mix with cement, mortar, sand, water together, and they make some scaffold and let it be hanged up using some spring. And it did perfect vibration isolation. So this was another experience I have appropriate technology. The thing that I want to emphasize in this lecture is that everybody has their own definition of the appropriate technology. But this is the definition that what I did. This is that it does not matter that it should be some high technology, low technology, or is it expensive or low cost, whatever it is, it does not matter. If you can solve some problem with whatever you can, with whatever you have. So this is the thing that I learned about the appropriate technology. So before I start, I want to mention about my organization. As I said, I'm a governmental research institute, but I made my company 4 years ago for doing some water purification and desalination, especially in the field of appropriate technology. The reason is, actually about 10 years ago, or actually 11 years ago, I just accidentally, at that time I was studied about solar cells. I have international collaboration with Middle East, like Libya, Arab Emirates, Kuwait, etc. And we did some solar cell development and field tests with those governmental labs. And I found that electricity is very important, of course, and it can be in as well as large size plant, or it can be small size, like a solar cell. So it can electric power plant can be in my yard with a small solar cell. However, water is more important than electricity for human life, but water desalination is that is very rare to have small scale desalinator in my yard. So I decided to develop small size, very easy to get desalinator by myself. So at that time, I made some idea and I tested at the rooftop and I got some result. And then I reported to World Water Forum and also COP21 in Paris. And that time, many people, especially from Africa, but also in all other parts of the world, they said that this is the one what they need. So why don't you make it and let it be implemented all over the world? So at that time, I did not make any company. So I did it just for hobby. This is for fun. So therefore, right now I cannot implement in the world. However, in future, maybe I can make let it be I develop more and I can be share it to the world. Then that's the reason I made one small company 4 years ago. Then I already reported it to the another World Water Forum in Senegal, and also CES, and then I got some good feedback from many countries. Those things that I want to present today, and I think that you can make by yourself such kind of technology maybe next year. Because I make a kit, several kit, and students can make it those technology by yourselves. So I have 3 topics. One is this is total appropriate technology, multi-effect solar steel, which is kind of desalinator with some small scale but effective one. And the second one is it might look like something modern technology. However, as I said very earlier part of this presentation, definition of appropriate technology is that whatever you can do, in that sense, could be another appropriate technology. And third one is the very small size water filter. Actually, before this week, I thought that this presentation should be go with the high school student. So I made this presentation for this one only, but I suddenly realized that the audience is university students. That's why I changed my PDF very urgently and make over this presentation. So first one is micro desalinator with the solar. Actually, this is the one that I started 11 years ago on the rooftop and tested. I named it Sosalino, Solar Desalination Innovation or Social Desalination Innovation. I got the CES Innovation Award in this January about this. This can be applied for not only just salty water but also seawater. And it is very some small scale, like a few liters per day, and it can be used only by solar power. No electricity, no fuel. Just it can be by solar and also just human hand. So idea is simple like this. Normally solar steels evaporate water and it condenses the vapor and collect the condensed water and drink it. So this is very simple, easy to make. However, while during the condensation process, the latent heat or vapor is all dissipated away. So that's why it is very, very low efficiency, even though it's very easy to make. So it can, normal solar cell is only used for emergency case or very particular cases, not easy to use in normal life. However, if you make multi-layers like this, and the solar energy hit the saline water or seawater, and it evaporates the first layer and condense the vapor, the water. While during the condensation, the latent heat or vapor reheat another seawater in backside, and it evaporates in the next layer. And then it condenses again, and then it generates latent heat again, and then it makes another condensed water, more and more and more. That's why this kind of structure has very high efficiency compared to normal solar cells. Actually, I'm not the genius who originally invented this. It was nearly 100 years ago they invented this. It was very fine. It's very, very, very well verified. Many papers. However, it was only did on the lab, not in the practical level, because it was too difficult to make and too expensive materials, too heavy to use. Because people normally use stainless steel for condensation, and also some glass, some wooden box, or metals, etc. So just like this. They did, even 1967, they made this kind of nice test at the lab. So I thought that if we can replace this kind of material with very low-cost material and very easy to make structure, then people can make it very low cost. Actually, this picture was taken very near here in Jakarta. It was made out of some papers and plastic films and polycarbonate plate, etc. People can use the water in the morning, put water on the top. It can be either water bag, or some bucket, jerry can. And water can flow during daytime, and it evaporates and separates to two fresh water and concentrated waste in two different ways, like this. So you can get fresh water, and you can get some concentrated waste. So this size, the area, effective area is about half square meter, and it can generate about 2 to 5 liters per day, a sunny day. It does work only a sunny day. If it is cloudy and no sun, it doesn't work because it is powered by only sun. The good thing about this is that I intentionally developed this to be producible in most parts of the world without having expensive machinery or very, very special tools. Just like as you see in here, like these simple scissors, knives, nippers, and then you can make using material just like this paper or plastic films. This is, I think, this is transparent polycarbonate, which is used for normally the wall of the greenhouse. It's really expensive, but it's obtainable from maybe Alibaba. Or the solar heat is absorbed by this kind of mulching material in agricultural purpose. So it can be, the material itself is very very low cost, but assembly takes some time. So next year, I think that I can here come again, and I can teach how to make it, how to use it, how you can get the fresh water. So you can do some field test. That's one thing. So that was the first object that I can do in next year with all of you. And second one is a little bit more modern technology. Previous one was good because it can use with the seawater and with only the solar energy. However, second one is that it can generate not few liters, but several tons, 100 liters, or several 10 tons of fresh water out of the salty water. I named it Desalino, so simply desalination innovation. There's no solar. I got another CES Innovation Award next January. And it cannot be applied for seawater, but it can be applied for some gray water, because at the seashore, there is a well or borehole which has some salinity, which is not very good for drink. By the way, if the salinity is higher than 1000 ppm, it can cause your health problem, chronic health problem, like high blood pressure or your some damage on kidney. So it should be purified. And also we can have some several hundred liters or tons per day. And good thing about this technology is that first one is that it can be powered by very small energy, not like reverse osmosis desalination, but it's less energy. I can show. So normally, if you want to do desalination in the small scale, not big one, I guess that 99% what people use is reverse osmosis right now. Reverse osmosis this is good technology. I mean, it's very practical. The theory is if you penetrate salty water through some reverse osmosis membrane, the membrane has very tiny holes, like a nanometer size hole. So water molecule can pass through the membrane. However, larger ions is blocked just by filtration. So if you push out, squeeze out all the salty water, then you can get fresh water, and remaining concentrate salty water is flushed away. So push out and flush, push out, flush. So you can get reverse osmosis to get drinking water, drinkable water with the salty water. However, this is the technology. However, problem is since you should push out all the water molecule, regardless of the salinity, it has used a lot of energy. In addition to that, the amount of water recovery is quite small, is almost 50% or less than 50%. So remaining is should throw it away. And the most serious problem is normally reverse osmosis membrane is difficult to make in every world. Assembling the machinery itself is easy. I mean, it is the simple structure, just like very strong pump, filters, and membrane. That's it. However, the core part, very core part of the reverse osmosis is that the membrane. And membrane, to make membrane, you need some large production facility, and it's expensive. So it should be imported from outside, and it's quite substantial cost for management. My solution is called the CDI, capacitive deionization, like this. This one has several layers of electrode. Like this, many layers. And while we add some electric field on the electrode, water goes through the channel of the electrode, and the ions, positive charge and negative charge ion, is absorbed on the surface of the electrode, and we get the remaining water to get fresh water. So by this way, you can adjust degree of the desalination. Some ion can be attached, some ion is just passing through. So you can get the fresh water relatively low energy. And in addition to that, you can adjust the water flow so you can get more recovery rate, recovery fresh water than compared to reverse osmosis. And most important thing is that you do not need to replace membrane, expensive membrane. Because I said the reverse osmosis membrane, they requires nanometer scale hole. However, this channel width is 100 micrometer, more than 1,000,000 times larger than the hole in membrane. So it is not easily clogged, and it can be theoretically it can be used forever. So it can be it has much less maintenance cost. And another thing is that it is though it looks like something difficult structure, but it can be easily assembled in most parts of the world, because it's nothing more than combination of power supply and pump and some valves, solenoid valves, and some controller. So by using, if you have some parts, then you can simply plug in all the parts, can make this structure and get the desalinator. Just like this, there's some electrode, and you can make some structure out of the desalinator. So you can make it with a very small scale, or by simply increasing number of the cells, the cell that means the electrode, and the power supply, we can make larger. So you can make small scale like carriers, or you can make like a factory water. You can make many applications. So by using this kind of some tools, some parts, you can by yourself can make some desalinator for your own. I think it could be useful because most students in here will be teachers, and they are working in all over Indonesia. And if you learn this kind of technology, and if you go to some other province and you teach some other students to how to make this, then this kind of instrument could be used for local society of that town, that village. It could be used, it can supply several hundred liters or tons of water per day, and it can be useful for drinking water for entire country. Actually, I did it before I came here, just last week. I went to Kenya, because Kenya has huge water problem. Not only salty water in seaside, but even inland, by nature, geologically they have volcanic rocks, and they have a high content of the fluoride. Kenya, Tanzania, and Ethiopia, like this area. So fluoride level is very high. So with the high fluoride, the teeth could be black, and also the bones could be crippled. So it caused many problems. And not only in Kenya, but all over the world, fluoride has some big problem like this. And also not only fluoride, but arsenics, heavy metals in groundwater. Not by pollution, but naturally there is. So they should remove this kind of some ion from water. Like this is one area, northern part of Kenya, in Turkana County. They have huge content of fluoride. By the way, WHO recommended 1.5 ppm is the maximum of drinking water in fluoride, but they have many places in underground water higher than 1.5, so they need to replace. So I brought one carrier size the desalinator, and I tested in the lab. And before, I'm sorry that this is too dark, you cannot recognize, but anyway, before the total salinity is 361 ppm, and fluoride level is 6.9 ppm, but after we treated, then we got 42 ppm salinity and 1.0 ppm of fluoride, which is perfectly is drinkable. So this kind of thing, what I want to do is that I want to implement the small size all over the Kenyan countryside, and people can make drinkable. Actually, this one is what I did propose to Kenyan, another university. They named Pioneer International University, and they have some good founder who also founded some big bank in Kenya. So I asked to make collaboration with me. Idea is that I can use my technology. I do technology transfer to them, and we can some human education and training for the students, and make some company, and they have some network of some bank network in all over the country. So we can implement this kind of some small kiosk through the rural area, so people could be avoid drinking fluoride water. This is one model, and once we can make such kind of some company, and we can make use of it. Then we can sell it to local dealer, and dealers sell global people, and global people make water, and they can even sell water itself, so they can more income, and they get fresh water, and also the more income for their economy life. This is one model, and makes very similar. But another way is that maybe I can use my technology and technology transfer, and you can educate you can train many people in here. Fortunately, it's not Dharma University, and in here this is very good at education, and people, the teachers and students get all the way to other province of Indonesia. Some province may not need this kind of things if they already have some good water. But some province, they need this kind of technology, especially in seaside. Then you can make either technology, like the first one, Dosalino, or second one, Disalino. You can implement such kind of technology at that province. And if required, then I can send my parts, materials, and technology, and also we can make some further optimization, further development optimized for Indonesia in that province, and we can implement this technology for this for you. So this is another collaboration model. Actually, the third one is kind of some demo. Oh, by the way, I think that I can have some Q&A before I go next step. But if you like that, I can go more, and then we can do Q&A. Which one do you prefer? It's okay. Okay, I just go ahead. Okay. So third one is kind of some absolutely appropriate technology. I did in 2015. There was big flood in Malaysia. So National Defense University of Malaysia, a professor asked me to make how to help their people, some project. So I developed some, it does another is water problem, because flood there's water is shortage, this is all contaminated. So I made some simple kit how to make some water purification or disinfection. Actually, this is very simple, as what the Professor Mac said, the sand filter, but it could be some smaller downsize, and I think that it could be useful for educational purpose. If you teach high school student or middle school student or even elementary school student, maybe it can be, you don't need to some bulky material, but you can simply make it. This is the one, very small scale. So whenever we have some disaster, normally for drinking water, what we do is that you just bring this kind of the bottled water in huge truck and bring it over there and distribute the water. It is really, this is not a good way, however, water is kind of heavy and bulky, so it is difficult to distribute. It costs a lot of budget. So the best way is that if people can purify by themselves and disinfect the water by themselves, it should be much more effective. This is actually this is a little bit too old, so absolute data. 1987. I think that there should be some better data and internet. But anyway, is the water pollution, especially the disinfection and infection, cause a lot of problem or health problem. So the one that actually it was already mentioned by Professor Meng before about the solar disinfection. This is very simple method of the disinfecting water. Simply put water, clear water, on this kind of plastic bag, plastic bottle, and just place this kind of bottle on the top of the rooftop with the sunshine. The bacteria or the microorganism is all disinfected by solar heat and solar UV light. And can drink. This is a very powerful way. So I tested it in Korea. I tested it in 2015. And this kind of the water sewage, I put some water on here. I added on the rooftop. And I found that most of the bacteria is killed. But problem is, if the water is taken out and it is stored in one day, then the microorganism is regrow. So you should drink it immediately after the solar heat treatment. That's one thing. And second thing is that the sand filter. You can make this kind of sand, and always water goes from the bottom, and it can go slowly go up, and from the top, water is dripping. So you can make some you can filter out some microorganisms and some dirt. So if you combine this technology, you have some better performance. So it was done at my small chemical lab, filling this bottle with sand, sometimes in charcoal, like this. And it is connected with some hose. And you can pour water, and it follow and flowing out and coming out. So it's very simple. I mean, of course, the sand filter that I showed before was also easy to make. However, sometimes it is too bulky that you demonstrate in front of the many students. But this is easy to make. Actually, I tried to make it in this lecture. However, I don't want to make dirt on this lecture room, nice lecture room. And it takes some time to water flow out. So I just making very simple demonstration without pouring water and sand. So in the bottom bottle in here, you cut here and making a small water outlet so you can flow out like this. And the upper bottle, you make more and you can make, actually I will make it over there. You can flow water and can get fresh water. After I make this lecture, then I will make simple demonstration. So by just tying up these two bottles on some trees or sticks, poles, whatever you have, and then you can use, and while you are just carrying it, you can just add some, you can block the top and then just carry as it is. Question is that how to verify it does work. The easiest way use this kind of some kit. You can add some droplet of water and you can incubate one day and you can count how many red dots exist. So you can test. That is I think the best way. However, if you want to check immediate result, you can use another way, which is we call the APP counter, like this. This is kind of some chemistry lab. There's a chemical named luciferin, and even luciferin has some oxygen and ATP, which is existing in living microorganisms. It is already dead. Such kind of chemical exists. So only it does work with the living organism like bacteria. And then you mix with the luciferin and this water with the microorganism, then it generates some light. So such kind of thing exists. So by measuring the fluorescence of this light, you can measure degree of the microorganism for test. This is the good thing of this is that you can see the result right away. But bad thing of this thing is that it's kind of really expensive. One test is about $5. So and also it is some special tool. Maybe if everything is allowed, if I am allowed, then maybe I can carry one unit in next time I visit in Indonesia. But anyway. So I tested these two technology. One is SODIS, solar disinfection, and the next one is sand filter. I named the plastic bottle added kit filter. Actually, I named this name intentionally because of my name. I'm like a pop. So I tested without treatment. The ATP reading is more than 2,000. But once it's filtered, 85% is removed. With the SODIS is more strong, 94% is removed. But if we do together with this filter and SODIS, 99.5% is removed. Of course, if we do this one, we store this water on the shaded area more than 1 day, the bacteria is regrowed. However, since it is filtered, it has the degree of the growth of the bacteria is smaller compared to just simply SODIS. Because there is few nutrients remain on the water. So this kind of way, you can make better result compared to simple SODIS, solar disinfection. It could be useful for real life, or for demonstration for educational purpose. So my recommendation is to use in both technology together, not just one. Actually, I took this picture in 2015. At that time, my boy was 4 years old, so I did great time with him. But I put this picture because it is very easy to make. Even 3 or 4 years boy can together for making this kind of technology. So if I have time, then I can just simply inform you how to briefly demonstrate how to make. Water cap is made out of the polyethylene or polypropylene. Good thing of this is that this is kind of some tough. So if you make hole, puncture hole, it's self-sealing, it's not brittle. And another thing is that this kind of bottle is kind of universal. If you use same cap, go back to Korea, Indonesia, or Kenya, wherever you go, it's same size, same dimension. Obviously, there's difference between the caps if you have some carbonated water, but if it is the non-carbonated water use the same dimension, so it can be used for in different way. So I make small water outlet, plug down the pump, and then small hole like this. This is a micro pipette tip. This is very cheap. So you can puncture like this. Because of this material is polyethylene or polypropylene, this kind of some top. So this is self-sealed. You don't need to have some sealing. That's here. So this is self-sealing because this is like a flexible material, like rubber, not rubber, but flexible material. And then you can cut. Like some more. I make another one. Simply pushing like this. Like that. And of course, you need some hose. I don't know, maybe you can find in some proper size hose. Like this, and you fill the sand. Fill the sand from here to here, but it's better to have some small pea size, some small rock in the bottom, and then some sand. If not, then the sand can flow down. But anyway, so you can fill all the way to here. So assume that there is some sand in here, and by raising up or down, you can control the water flow. If it's too very high water pressure, so you can control water flow. And if that is not enough, of course you can add some clip in here, so you can adjust the clip and you can control. The important thing is you should do it very slow. I tried it. I'm not a very patient person, so if you try very fast water running, then it's not filtered very much. You should drip it down, top like this, yeah. So you can control it like this. If you do not have this kind of some tip, this is very common in chemistry lab. However, if you cannot find that, another thing maybe you can some small like 4-point pen, like this tubing. You can use whatever you want. So everything is okay. So I'm sorry that I did not brought sand and water in here, but maybe you can do it. It's very simple, so you can make. And important thing is that you should, before you using, you should try water as much as possible because the sand itself is not clean. I mean, if you go to digging some sand, then it includes bacteria. So to use it before using, you should throw down water many times, and then you can finally get some clear water. So using that clear water, you can use the solar disinfection for further treatment. Thank you. So do you have any questions? Maybe this is too simple demonstration, but you can go and you can do by yourself within just 10 minutes.
Do you have any question, guys?
Not only this, but the previous one.
Oh, there's one question from me. Yes.
Do you need a microphone?
Okay, thank you for the time. I have interest in solar filters at the first presentation. The seawater has various contents, not only water but also salt. It can be sodium chloride, NaCl, and or maybe another salts like calcium and magnesium. Earlier that you explained that solar filter can separate sodium chloride from seawater through the seawater desalination process. Can other compounds also be separated with the same tools, or if not, has been there any innovation to separate other components in seawater? Jadi ya kalau di tadi penjelasan itu kan dari solar filter itu kan bisa memisahkan antara NaCl dengan airnya gitu. Tapi kan air laut itu nggak cuma NaCl gitu. Apakah komponen selain NaCl itu bisa dipisahkan dengan alat tersebut? Kalau iya, gimana? Tapi kalau enggak, ada inovasi lain atau enggak gitu?
Yeah, could you please interpret yeah, I understand the audio part, but the later part maybe you do better to interpret it.
Maybe the solar water can be selected in other systems other than NaCl. Maybe
Okay, yes. Yeah. Alright. So that's a good question. Actually, this is not filtering anything. It is distilling it. I mean, it evaporated to the molecule, in molecular level, and it condenses. So it is not filtered. By the way, this one can capture. It can be filtered out. It is not filtered, but I can say that filtered out, or dissolve the thing. No matter what it is, ionic, but like a sugar, or everything is dissolved. It cannot evaporate. Then it can be filtered out. However, since this is evaporated all the water molecule, it cannot distinguish sodium chloride, potassium, or sugar, whatever. It cannot distinguish separately. It only removes the non-dissolved, the dissolved thing. That's one thing. And second thing is, even though it is dissolved thing, to avoid the dissolved thing like a salt, to clogging in this evaporation layer, some sort of the water should be flushed out. That's why it has two vessels. One is the fresh water, the other one is some solution of the salt and the water, not the salt itself. If the solid salt is coming out, then it's clogging inside. So always some water flow should be carefully controlled to get concentrated water, not the salt. Yeah. Is that answer? Thank you. And one more thing is that even though you add some dirty water, like some cloudy water, it's okay. because in this kind of technology, it evaporates everything. So even though you add some like, not absolutely muddy, but some sort of the muddy water, it is blocked on the paper, and another remainder is coming out. So you don't need to worry very much about some pre-treatment. So any other more questions? Oh, come on, is to try.
Adakah lagi yang ingin bertanya?
You can ask in Indonesia because there's good interpreter. Yeah.
Test. Okay. Thank you so much. I want to ask to you about the first question. Indonesia often floods, so can this technology be implemented before the rainy season and then used? Okay.
Oh, yeah.
Second, can we use flood water with this technology? Because access to clean water during floods in Indonesia is difficult.
Would you say the second question again?
Okay.
Because my English is not good, so please, yeah.
Mungkin moderator bisa translate lagi. Bisa nggak kita gunain air banjir? Karena kan akses kita ketika banjir kan air bersihnya terbatas gitu. Understand what I mean?
Okay, so the question is, in Indonesia, there's so much floods, so can this technology be implemented before the rainy season and then used? Like
Prepare before the rainy season and used. Yeah. So first question, you said that it can be used for the rainy season. Answer is that this technology cannot be used. It can be operated, powered only by solar heat, direct solar heat. So partial smaller solar energy, you get smaller water. So larger direct solar heat, you can get more water. But I think that it could be useful only at dry season. I mean, normally at rainy season, you don't need to worry about water. You can just collect rainy water, you can just filter out the standard filter, and people can make use of it. Only the matter is the dry season, which has the less of the energy and less of the water, and also the seawater intrusion to the groundwater is more severe at dry season. So I think that it is only for dry season. That's the first question. And second question is that whether we can prepare this one before. Yeah. Yeah. The question is that you can use. I think that you may choose not only one technology, but you may choose several. You should know the several different technologies. And if you have some this situation, you do better to choose this one. You may choose in this situation. You may choose the other technology. For example, if somebody is isolated in very remote area, just by one family, then it is not very practical to have expensive machinery over there. In that case, maybe it's better to have some simple appropriate technology like this. However, if you have some village, you have some society, and with several hundred people or several 10 people, in that case, it's more practical to have some larger machinery and let it be operated by yourself. And also it can be operated by the solar panels. So preparing that, it can be useful for that society. and it can be implemented easily. And based on some education and technology transfer, I think that you can do it by yourself, even not only this kind of simple thing, but also this kind of some little bit more looks like some complicated thing, simply just plug in as far as you have some parts and material. So everything is on your hand based on technology transfer. Is it the answer? Yes,
Your presentation was very interesting, especially the technology of CDI technology. As I know, that technology was not actually used even about 5 or 6 years ago. Or is this CDI, I know the principle, but I would like to know whether it is actually used or adapted. Yeah,
I guess yes.
Yeah, adapted.
Yeah,
because this is kind of very new technology.
Actually, of course, again, I'm not the genius who invented this. It's already existing technology. I think that I'm not quite sure, but they still from the Germany. They already started to make this technology. Yes, my answer is yes. There is some practically is applied in Ethiopia, in Senegal, and I think in Tanzania. They are using this kind of not from my company, but some other Korean company. They made it, and they are making use of it without breakage. 7 years, it was fine. As far as you maintain it very carefully, then without replacing the electrode, it can go more than 6 years or 7 years. That's one thing. And another thing is that this CDI technology, normally, it is not very usable for high salinity up to 1000 ppm. That's why it's very rarely used, I think. But we made some progress on this structure, which can be used 1,500 or 2,000 ppm, which is normally normal concentration with the high salinity of the underground water in well. So I think that it is applicable even in Indonesia. Previously, this very limited application in Kenya or in Ethiopia, etc., because normal previous one is very difficult to apply in high salinity. So only limited one like high fluoride, high arsenic. However, I think that I increased the salinity limitation, so it could be useful for the seashore of the groundwater in Indonesia also. Yes, I hope. Thank you. So, any more questions? I see. Yeah. So, if you have a question, then you can personally come after here, and next year I will come back and do these two technology. So if you want, you can join me and we have some funny time. Thank you.
Okay, thank you for the great presentation from the first speaker. Maybe someone can help me. Okay, well, you are clear now. Maybe let's just move on to the second speaker. Okay, for the second speaker, time is yours.
Hello, everyone. Final lecture today. My name is Yantek Wu, and we gotta make some solar boats right now. So, but we only have 20 solar kits. So 3 people make 1 group, right? Okay? Yeah, 3 people make 1 group because we only have 20 solar kits.
Tiga. Silakan cari partnernya teman-teman, 1 kelompok 3 orang ya. Okay, are you done with your group? Okay. Next slide.
Oh, before the practice, I have speed quiz. And anybody who knows the answer, please raise your hands and please let me know what is the answer. Let's 3, 2, 1. Oh, Saratadama. Green. Yeah. One, I have some products for the Korean food. Malang I will give you. And next quiz is 3, 2, 1. So many people, but I have enough Malang. Never afraid that. Yeah. And last quiz is SC. Oh, WB. Okay. everybody, the champion this quiz. So I have 60 Malang. So enough, maybe. And after my lecture, I will give you 1 Malang, okay? Yeah. And we are gonna start the solar panel board assembling practice right now. So I need some help because the contribute about the kit. One group, 1 kit. Yeah, 1 group, 1 kit. this lecture is not a formal lecture. We gonna just practice, and this kit make Hanyang University, and this is educational material for the middle school and high school students. So let's practice. But caution, be careful not to injure yourself, and be careful not to lose any parts, because there are so many parts. So be careful, and be careful not to break parts with foam board. This is so weakness. Okay? So let me check all about kids parts. One set of foam board layout and styrofoam 2-piece, one solar cell, water wheels 2-piece, one sticker, and ground gear 1-piece, screw gear 1-piece, wire rod 1-piece, and sponge double side tape 2-piece, and solar cell holder 1. Let me check.
Dicek dulu teman-teman udah lengkap atau tidak.
Scissor. But when we use scissor, I will have 5 scissors right now. So we should take here, but not yet. Not yet. It's okay. Yeah. And first, let's go. Place the sticker on the top of the boat. Let's do that. If you have any question, please let me know. Here is so many doctors in here. Yeah? Yeah. Separate. Yeah. Separate. You can see that hole, so separate. Done? Do you need more time? Okay.
Sudah selesai kah? Oke.
Next, we're gonna go. Okay. Second, tape 2 long pieces of styrofoam to the bottom of the boat with double side tape, and paying attention to orientation, because 2 types of styrofoam have directions, so you should check where is the front, where is the back. You should check. Oh, we need scissors right now. Maybe, right? Maybe more. more scissors. Besides, buttermilk is outside. We should take down. Besides, right, correct. Correct. Yeah, correct. Yeah. And you should leave some drop. Yeah. Done. Next, you gotta go. Detach the rollings on each side, but from the forward set and attach stickers to them. The side. Easy, right? Yeah, easy. Next is a little bit hard. You should check the first, second, third is what is the first is water wheels and board, gear supporter, ground gear, board, water wheels. In the steel bar. You should assemble careful. Yeah, it's still in here. Oh, in here. Bar, steel bar. some power into the button and like this. Where is the board? It's okay. Do we need some time more? What are you doing? Yeah. But it will be work. Professor Lucia already done. Finish? Oh yeah. Oh yeah. Oh no. some students already finished. And could you yeah, next slide. One more. And when install the screw gear on the motor and connect it to the solar cell, you should remove the cover, and each color should connect and twist the copper. And take care your hand. Good. Thank you. Everybody finish? We should some practice in the solar energy. Is it work, hey guys? Yeah, it worked. Yeah, this lecture is almost finished. Hey guys, so we gonna finish this lecture and I need some more the slide. So could you sit down right now? I need some time. So, do you know why solar cells are the dark? Anybody know? Why solar cells are dark? Why?
Karena hitam menyerap panas. Karena hitam menyerap panas.
Because this is due to the color of the material used in the anti-reflective coating. We use silicon nitride, so that color is dark. And I'd like to introduce this site. This site, you can access this URL, and you can see that this like this: solar, wind, hydrogen, and hydrogen, irrigation, it's not a chemical word. It's about the climate technology. And you should check this site. Global Climate Tech Landscape. I recommend this site. And you can see the company through this site. Students can access information from a variety of the companies involved in solar power. And in this case, solar power is being generated on the surface of idle rivers and lake in Korea, like this. It's solar panel. And the source global water have huge raised from the breakthrough energy ventures from Bill Gates. Very huge dollars. So solar panel has a potential and very easy technology. So I don't like to introduce this information. And maybe Dawn. Finish. Yeah. And when you go outside, you can take one malakal from here. Yeah. Everybody.
Siapa yang mau bermain?
That's my private.
Ada yang belum dapat?
Saya.
Oh ya.
Belajar multitasking.
Ada yang belum dapat?
Apakah ada pertanyaan lagi teman-teman terkait materinya? Ada lagi? Okay, so because the time is over and we have been listened to the presentation from the speaker, so now okay, now let's take a photo together with the speakers. So I invite the speakers to come in front. Let's take a photo together. Ini pembicaranya dulu yang foto pertama. Oke, semuanya cek. Oh ya. 내가 살짝 진짜 가자.
say Professor Joe. He said, say hello.
Okay, guys, let's give a big applause for the speakers and the moderator today. Okay, and now the next agenda is we will sing the Sanata Dharma hymn. I invite all the audience to stand up and clench the right fist on the left chest. Thank you, and the audience is allowed to sit back.
Our beloved audience, now we have to come to the end of our event. Thank you for your enthusiasm for today's seminar.
We would like to take a moment to express our immense gratitude to the team who have made this seminar possible.
And we are truly thankful for their effort and contribution towards this event. Let's give applause for them.
Now we will close this event with a prayer that will be led by Mutiara. Time is yours.
Ladies and gentlemen, let me lead the prayer according to Muslim religions. Let's pray. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan yuafi nikmahu ya Rabbana walakal hamdu walaka syukru. Allahumma sholli ala Muhammadin fil awwalina wal akhirin. Subhanallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar.
Alhamdulillahirabbil alamin.
Thank you, Mutiara.
Ladies and gentlemen, we would like to thank you for entrusting us to guide the event today.
We apologize if there were any mistakes and shortcomings on our part during this event. I'm Nelson.
And I'm Hannah.
And see you in another
time.
time.
Thank you.